Alright, this next video is going to deal with force. Okay, and force is one of the fundamental things with classical physics. It's the things that make all the things move. So, before we were talking about velocity and acceleration and speed. Forces are what's going to make those things happen. Okay, so to define force real quick, force is a push or pull that causes motion. Okay, and the other kind of big addendum to that is that you don't necessarily see it. Okay, so for instance, okay, gravity is a force, okay, but you don't see gravity. It's not like something that you can see just out and about. You don't walk around and be like, oh, the gravity is nice today. You don't see it, but it is pulling on you. It's pulling you towards the earth. The same can be said for friction, right? If you're running, the reason you don't slip and fall or slide or, fly away every time you start to run is because of friction. It's holding you to the ground. Okay, those forces are not seen, but they're there. Okay, that's why force is something that's relatively new in the last 300 or 400 years when we figured out that these forces were, because we couldn't see them. Okay, there are two types of forces, and that kind of gets to what I was talking about. There are contact forces, and then there are non-contact forces. Okay, a contact force might be me like literally pushing you. That would be a contact force, right? Or potentially, contact force. I'll come up with another one. Non-contact forces, we've got things like gravity, electrical force. There's lots of different types of non-contact forces. And these are things that affect you without touching you, right? Gravity doesn't reach out of the earth, grab you with its big hand and pull you down to the earth, right? It is a force that is exerted in a field, so it is a non-contact force. It's not touching you, but it still acts on you, okay? There is an equation that allows us to calculate a force, okay? And that equation is pretty simple. It is the force is equal to mass of the object times acceleration. Okay, so we've got acceleration, which we learned about a little bit ago, and mass, which is how much of you there is. You multiply those two numbers together and you will get a force, the force that can be acted upon that object. Okay, there is a unit, of course, that goes along with force, and that unit is called a Newton, after Sir Isaac Newton. Okay, and a Newton can be broken down into a kilogram meter per second squared. That's what a Newton is. Okay, so if you're ever dealing with a force like gravity or a push or a pull or anything like that, you're going to use newtons as your unit. Okay, so let's solve the problem real quick just so we can kind of see how it's done. Over here it says, if Mr. Mangian pulls his son on a sled, which has a mass of 25 kilograms, that would be the sled and my son, okay, at a rate of 2 meters per second squared, that's an acceleration, what would be the force I needed to exert to make that happen? Well, I would do is I would take my mass, 25 kilograms, and I would multiply it by my acceleration, which is 2 meters per second squared, and I would get my force. So 25 kilograms times 2 meters per second squared, that's 50 newtons, and Newton is just a capital N, and it's very easy to remember, and that would be my answer, 50 newtons. Okay, you could write down kilogram per meter times meters per second squared, but nobody wants that. They just want newtons. That's much easier to work with. Okay? So just remember, forces are anything that has a push or a pull that causes motion. Okay? Sometimes they don't cause motion, right? They're trying to exert a force on it, but it's not actually making things happen. Okay? Those are still forces, but generally they're going to cause some sort of motion or action. Okay? And that's just an easy way to remember it. There are two types, ones that involve contact and ones that do not involve contact, so like gravity or electrical forces. There's an equation, F equals ma, and when we solve our problems, we have a unit, and that is newtons. And that is what force is all about.